So I want to talk a little bit today. We hear about number sense, number sense, number sense. And I think there's become sort of a idea of what number sense is. And it's kids who can work with numbers. But I'm challenging that today, and that's why I'm calling it a sense of number. Thank you. So what do you see? Can click. What do you see? Do you see a lion? You see the word lion, or you see the letters L-I-O-N, okay? But you don't see a lion. If you didn't know what a lion looked like, or you couldn't read, you wouldn't know. Next one, please. What do you see now? Is that the number 7? No, it's not. It's a symbol, okay? It's not the number 7. I know I'm treading on some toes now, but that's not the number 7. Thank you. What do you see now? A picture of a lion. But if you've never seen a real lion, you would still probably recognize one if you had seen the picture. Okay. What do you see now? What do you see? I heard 7 dots. Okay. Or what else? 7 dots? Is that all you see? 3 dots and 4 dots? What else? Green circles? Are you seeing, sorry, if we can go back. Are you seeing what I'm saying? That picture of the 7 circles, that is also not the number 7. That is a visual picture of the quantity of 7. But the symbol makes little sense without the picture. Okay, we can carry on. And the same there. What do you see? You see dice. What else? Black dots. 5 and 2. You see how long we took out to come at the 5 and 2? But again, picture of 7. Is it the same picture of 7? No. Let's go. What do you see now? Zebras and apples. What else? 1, 1, 3, 2. 5 and 2. 3, 3, 1. Okay, so those were all representations of the quantity of 7 without the symbol. Okay, so what is a number? A number is actually a concept that happens in our minds. A number is a concept that happens in our minds. If you tell a child, go and show me 7, and they point to the symbol of 7, that does not mean that they have a sense of 7. Even if you say to me, show me 7, and they go, 1, 2, 3, 4, 5, 6, 7. They've only gotten to 7 as a count. They have not gotten to 7 as a mental concept in their minds. Are we together on that? Okay. So that's what a mental object is. We can go on. It's the written syntax that is used to communicate numbers is what a symbol is. And the written syntax that is used to communicate reading or words is letters. When do we start teaching the children the letters? Grade R? When do you often see children learning the symbols? Already in the creches, hey? Do you see the toys? They all have the number. But when are the symbols, when are the symbols actually only needed? They are only needed when we start to communicate in writing. Do you hear what I'm saying? So why are we introducing them? We hold them back in the reading. We hold the letters back till they have to learn to read. Why are we forcing the symbols, which are also only a form of communication, so early? And the problem is it's not allowing the development of the visual of the quantity. So that's the basis that I'm coming from today. And my talk today is actually one part of 2 parts, which I'll complete in the reasoning session today at 3 o'clock or tomorrow. So let's go on. 7 is just a symbol. Letters are the written syntax to make words, like L-I-O-N makes lion. Symbols are the written syntax to make numbers, to make values. If you don't understand that the 1 is not a 1, what is that 1? It's a 10. then actually, and we see many kids splitting the 1 and the 10, the 12 as 1 and 2. But can you see in the picture of 12, that is the number concept that we need kids to develop in order to get a sense of number, rather than just number sense as in numerals. Thank you. So how does a young child learn what a lion is? I'm curious. Pictures. Would that child looking at those pictures know that a lion has one tail? No, they get shown different pictures. Some have got 4 legs, all lions have 4 legs. But if you don't get a picture of the legs, you won't know that. And it's the same with the quantities. Go, thank you. Learning what a lion is learning to read the word lion are 2 different processes. Do you agree with me? You learn what it is when you're young. Later, you learn how to read it. But somehow in maths, we've not made that distinction. We're teaching the symbol at the same time as trying to teach the picture of the quantity. And this is what I'm pushing for today. Let's go. So, seeing the picture is like a runway. What lands on the runway? The aeroplane. The aeroplane is that symbol can come in. Thank you. So that creates a landing place for the word lion to land on. And the same with the symbols. The next one, the same goes for numbers. You've got a landing strip, which is the picture of 8, and then on that can land, thank you, the symbol of 8. Okay, let's go on. So what are these that we've been working with? They number names. They're not the number. They're the number name. And what else? Press, please. Number symbols, which we actually call numerals. Okay, what else are they? Press, please. They are also digits. Okay, again. So there's the digits, and again. And now look what happens. I did magic. They were digits, but now what are they? They are values, hey. That 7 is a digit, but it's representing 700. So this is the thing I'm trying to get from, that being able to write 710 is not number sense. Even being able to perhaps complete a sum of 710 plus 21 is not number sense if you're just following a method. The number sense is in the composition of a number as another number. The 7, the 1, and the O form, they are all in their own right numbers. Do you understand what I'm saying? But as a combination, they form another number. And so a sense of number is understanding how numbers combine. Let's go on. I want you just to have a look at this video quickly. You can play? Thanks. This is a grade 5 learner. There doesn't have to be sound. You can see what he's doing. Is this number sense? Is this worrying you? But do we see this a lot? We see this all the time. He's counting every single dot again and again and again, even though there's only one more dot. So there's been no sense of a pattern. There's no sense of spotting. There's no spatial reasoning happening. For me, we are calling that number sense because he can count. And that's where we're making the mistake. That is not a sense of number. And that's what I'm talking about today. Let's go on. So unfortunately, number sense is often equated to being able to count and work with symbols. But it's not necessarily the case. Have a look at that. That is a grade 4 learner that has done 7 plus 8. Can you see what they've done? They've learned 7 as a count, and they've learned 8 as a count, and they're having to count all to get to the answer. And you see the same has happened, 30 plus 500 plus 7. They've added 3 stripes. They're working with each one as a digit. And of course, you know the whole rule of recomposing. Take the first digit from each, because we teach that as a rule. And that is not teaching into the sense of number. Let's go on. So I think that we start teaching numbers in grade R and 1 by immediately introducing the symbol. with all respect to the DBE, the very first page is the 0 or the 1. It's the symbol and then follows the pictures. And this really worries me because the symbol becomes the precursor to do maths. But it's not. You have to have the picture in your head for the symbol to land on. And this is why I've actually got I have a consultancy called Bush Maths. And we made these cards. I'm going to give some of them out. Some of you have got them that work with pictures. But I've changed the name now. I'm registered now as Young Game Changers because we want to go for a wider audience. But also because the minute I say I'm in maths and people take the cards, they're like, but where are the symbols? You can't do maths if you don't have symbols. But that's not where it begins. And we are the ones building the foundation. We heard all of that this morning. We need to develop the pictures so that the symbols can land. And we can have robust kids who see many pictures. And so that's why, we have to break that thing of maths is just about symbols. So, sorry, I was still on the last one. The other mistake I think we are making, or I'm suggesting, is that we are introducing children to numbers as counts instead of compositions. And now you're like, but what? We've always done it this way. We have, but let's think about how we can do it differently. Now we can go to the next one. So I think we need to try and make sure that grade R's and grade 1s have visual pictures of different ways that the same quantity can look before we even come with the symbol. And the other thing is that we introduce kids to quantities as descriptions and composites and not as counts. What does that look like? That's what we're going to talk about. Thank you. What do you see? Yeah, there's a picture of a lion. What else? 2 cards on 1 apple each. So let's say I don't want to teach a child to count. Maths counts, but we don't have to have the children counting. So let's say I only teach them 1 apple. That's all you've been taught. You're a little grade, you're 3 years old when we start this. You're 3 years old and you know 1 apple. Now tell me what you see. No, you haven't learned 2 yet. You've only learned 1. 1 and 1. Excellent. The 3-year-old has just done addition that they're only going to learn at 6 years old. But we haven't called it addition. We haven't said you must put a plus. We haven't made it complicated. It's a complete natural composition of 2. What is the name of what you see? The collective name. What is it? It's 2. But if you describe what you see 1 and 1. Are you with me? So this is a way of introducing kids not as counting 1, 2, 3, because if I hear 3, I know it comes after 2, but it doesn't mean I have a picture of how much it is. Okay, so let's go on. So 1 and 1 is the description. So I'm much more propagating now to teachers that we talk about what do you see? And then we talk about what do we call it, okay? Because right here, you see me, you see Hannah. But if you were calling me on the program, it would be Dr. Hannah Barnes. That's different, that's my name. But this is what you see. And it's the same with the cards. Let's go on to the next screen. There you can see the collective of 2. So that one we can call it 2, but we still see 1 and 1. Let's go on. Go on. What do you see? 1 and 1 again, but is it still apples? No, because if I only showed you apples, you'd think all 1s are apples. So it's 1 and 1 what? Sticks. And it's important we talk about this. 1 stick and 1 stick. What do we call the 1 and 1 together? We call it 2. I'm talking about a 3-year-old child, okay? Now I've taught them 2. Now they're going to start to recognize 2s. Let's go on. I'm going to teach them 3. What do you see? 1 and 2. Because I've learned 1 and 2, haven't I? What else could you call that? How else could you describe it? 1 and 1 and 1. And that would be fine. Okay. So the child is now at 3 years old learned that 1 and 1 and 1 can also be called 3. It can also be called 1 and 2. It can also be called 2 and 1. Do you see how much more flexible this is? They haven't only learned 1, 2, 3. They've learned a whole composition of 3. Now we take them up to 10, and then we start teaching them bonds of 10. We teach them 10, and then we start teaching part, part, whole. We are teaching part, part, whole intrinsically the whole time. It's part of the way we are teaching it. It's not a tool. It is part of the methodology. Let's go on. Now this one is a bit different. Do you see? The last one you had 1 and then 2. What do you notice here? 2 and 1. Has the name changed? Has what it looks like changed? Well, it has actually, because the arrangement, the structure is different. And this is what kids need to learn about maths. The structure can be different, and the value can still be the same. And that's the difference between learning a number as a composite versus a count. A count is a count. It's the name. That's it. Okay, let's go on. So let's stop at 3 for a while. The child is 3 years old. We stop at 3. So I've got some packs of cards I'm going to give away as well, and that's what we use with the kids. We say to them now, for example, go on, please. Find all the apple cards to match those. I don't say what the names are. Do you say what I'm saying? So what will they find for the 1 dot? 1 apple, 2 apples, 3 apples. Okay, now they are learning it's a different object. It's arranged differently, but what's the same? The quantity or the name is the same. And we all know that's called conservation. All right. So they're learning so many skills without us actually teaching it. We're not saying this is called conservation. A 2 looks like this. They learn it by matching. Okay, let's go on. Oh, by the way, you can also start even the geometrical spacing over here. There's your 1 line, your 2 lines, your 3 lines. You know what I mean? You're starting to get the idea of a triangle. Okay, just a lot of things we can do with the quantities. And you can also ask them, find all the cards that have 2. Let's go. And so these are our cards. And so what is 95 plus 8?
103.
I heard it over there. There's a pack of cards. So we're busy rebranding the cards, and we've now split it into 3 games. It goes up to 5 for 3 and 4-year-olds. So we only take them up to 5. And then it goes up to 10 for grade R and grade 1. And then it goes up to 12 for grade 2 and 3, so that you start forming the 10 bases. Okay, so those are all. I want to talk a little bit about spatial reasoning. Do you notice the way the zebras are laid out? How is it laid out? They do. They go down, hey, in a pattern. So it's 3 and 2. So now the child sees that if they've learned in this way. They see it as 5, but what else do they see it as? A 3 and a 2, or a 2 and a 3. And when we're asking them, what do you see? We're also asking them not just the quantity. There are other ways of seeing that. There are zebras. There are black and white stripes. There are green dots. What do you notice about the 2 and the 2? It's been doubled. It's been repeated. These are conversations I can have with a 4-year-old without explaining what the meaning of doubled means, just by describing what we see. Let's go on. What do you see? I need someone. What do you see? Red apples. What else do you see? 7 and 2. Sorry, what else do you see? Sorry? 3 and 3 and 1. 3, 3, 3. What else? Double and add 1. And what about the other 2? See, so some of you are only focusing on the part, am I right? But you have to also talk about the whole. There are 2 parts. There's the 3, 3, 1, but then there's also the 2. We still have to describe all that we see. Nobody told me you see a whole lot of stems or a whole lot of leaves. Am I right? Or just 2 cards. You see, there are much more things we can be looking for. And I think when we focused on symbols and number as a count, that's all we look for. We don't open the mind of the child to look for more. Let's go. So, these are all various ways of describing what you see. And tell me if you think any of them would be wrong. Are there any wrong? Are there any that are more accurate descriptions than others? What do you think is the most accurate description? 9 apples is the count. But I think the most accurate one is actually 3 rows of 3 apples, or 3 columns of 3 apples. Do you see how I've started now using the word rows and columns? I'm working with arrays in grade 1 already without calling it arrays. So when I get to multiplicative reasoning, it's built in. I'm not trying to teach multiplicative reasoning of symbols. I will extend what's already been put in place. And I've taught no counting yet to these children. Let's go on. Now, what is that? It's actually Zulu, by the way. It's Zulu or Ndebele. But that is the name for 9. Let's go. Thank you. Now you'll see it in all 11 languages. This is not 11 different ways to describe 9. It's the only way to describe the name of 9 in 11 different languages. Do you see how much richer the last slide was? If I know the name of 9, the only way I can just talk about it in other ways is if I go learn the other 11 languages. Do you see how I've grouped them? The bottom is Sesotho and Setswana. Up there is Senyane, is Sepedi, and Setsonga. Toba and Tahe is Venda and Islikosa. And then in the top up there is the more difficult ones, Ndebele, Zulu, and Siswati. Siswati doesn't really have anybody patterning it. Okay, but that's the only way you can do 9 in different ways. But when we ask the children, what do you see? And we give them a picture, do you see how they can describe it? Let's go on. So have a look there and tell me what you see. Let me do it like this. What do you see? 5 white blocks. That's interesting. She focused on the empty spaces first. 5 blue dots. What else? 5 blue and 5 white and 5 brown. 3 and 2. See, we are very trained to focus on the collective instead of focusing on the partial because we've been taught numbers as counts. If we train children to start noticing 2 and 3, that's the first thing they're going to notice. So I want them actually describing it as 2, 2, 1, or 2 and 3. And then what do we call that? We call it 5. I hope you can see the difference. The one I'm asking, what do you see? You also see 5. But the what do you see means you can describe it in many different ways. What you call it as a whole collection is only 5. Okay. Yes? Absolutely. And if you come to the reasoning session, I talk exactly about that. Because later when you're talking about 18, and you want to add 18 and 17, what do you need to be able to do? You need to be able to break up the 18 into 10 and 8. So it's that whole composition. But let's go on. Oh, by the way, these are toys for trash. We take boxes from schools. They bring us their trash, and they get a kit back, and they can make an educational resource from it. So it's called Toys for Trash. Everybody can make one of these. Okay, let's go on. So the description of what do you see is 5, or 2 and 2 and 1, or 2 and 3 and 4 and 1, but the name is 5. Let's go on. So, what do you see? 2 and 2 is the description. The name is 4. Let's go. It's a bit difficult when I can't control. What do you see there? 3 and 1. I've used 2 different cards. There's a 3 card and there's a 1 card. Or I'm using a 2 and a 2. So this we are doing with grade up to 4 years old. We'll go up to 5. Let's go. Okay. Now, when we get to 5, the number 5, it's the first marker. So in grade 1 and R, we teach up to 5, the name. And after that, before we talk about 6, what do you think we talk about? We have already spoken about 3 and 2, but I want a more systematic one that can take me all the way to 10. 5 and 1, 5 and 2, 5 and 5 and 5 and. What is the name of 5 and 5? I've just taught the bonds of 10 to a grade R child without teaching them addition or bonds. Do you see? Because they've learnt 6 as 5 and 1, 5 and 2, and they can see it, 5 and 1, 5 and 2. I then tell them it's called 6, but they don't only know it as 6, they also know it as 5 and 1, which saves me a whole lot of time when I have to start teaching addition. Let's go on. So you can see 5 and 2 is the description, but the name is 7. And if we can let children get this feeling, I think it'll be a much more natural working of numbers in the manipulation, because that's what maths is all about. It's all about being able to manipulate. But if you can't break down a number with meaning, the manipulation becomes a method. And I'll talk about that today later. Okay, let's go on. So those of you that are using the science of reading, you've been using this synthetic phonetics, you've been talking about chunking, you've been talking about blending. This is almost like chunking and blending. 5 and 2, but together it's 7. I read cat walk, but it forms the word catwalk. Do you understand what I'm saying? I'm trying to use terminology, and that's what I want to do with Young Game Changers. We're trying to draw together what are you doing in literacy and what are you doing in numeracy so that it forms a holistic picture for the teacher. Why? I know there are two different disciplines, and I don't mean to undermine that. I'm not a linguist. But we can still be talking about a similar language that makes it accessible to you to understand what I'm doing in literacy, I'm implementing in a different discipline, but in a similar way. Okay, so this is similar to chunking and blending. Okay, so let's go on. There you can see 5 and 4, which is called 9. And again, on the 9 card, it won't look like the two cards I've held next to each other, but that's the whole one-to-one correspondence that the kids need to learn. What we also then do is we put the card here, and the child packs it out on the 10 frame. So we're not using the 10 frame to teach addition. We're using the 10 frame to teach the quantities, to create that number concept. Let's go on. And then we get to another picture, for example. What can you see there? You can see 5 and 2, but you can also see 2, 3, 2. 2 and 3. And I'd encourage you to let them put the word and in between. Like in Sepedi, we'll talk about pedi le taru le pedi. 2 and 3 and 2. You know what I mean? So that they get that word and that we can later replace with a plus. Because then they will understand collection. So the breakdown is 2 and 3 and 2, or 5 and 2, or 4 and 3. Are you starting to see it? Can you see all the parts? And what is the whole collection called? 7. If I want to replace all of those with one card, the one quantity card I must look for is 7. Okay. Are we together? Is it landing with you? Or are you like, it's okay? Okay, let's go on. So by now, a child has learned to see composites. Let's go. You can just keep. So a child should be able to see all of those. 1 and 1 and 3 and 2. Are you starting to see it? Seeing the partial sums, we call them, hey? 2 and 5, 5 and 2, 3 and 4, 2 and 2 and 1, 6 and 1, 1 and 3 and 3, 1 and 6. We should have this in grade R. A child should be able to see this in grade R, not in grade 4 or 5. Let's go on. Yeah, we then come to the next marker, which is 10. But the child is now very comfortable. They're used to going 5 and 1, 5 and 2, 5 and 3. So they just start to go 10 and 1, 10 and 2. Can you see our number patterns starting to unravel? This is the decoding of your reading science. We have to teach them to decode our number system, and this is how it works. They don't see the patterns. We have to teach them the pattern of 5 and 1, 5 and 2, 5 and 3, 5 and 4, 5 and 5. But if we then went 5 and 5 and 1, we'd all be very tired. So we go 10 and 1, 10 and 2. Okay, and there you can see the collections are now starting, the grouping. What do you see on the left there? You see 5 and 5, or 10, but you also see 2 groups of 5. You see the multiplication starting to come in? 2 groups of 5. Or, no, you're only seeing 2 groups of 2. You're not seeing 5 groups of 2. And this is what's happening, kids, as well. The answer is still 10, but you are not seeing 5 groups of 2. You are only seeing 2 groups of 5. And in the next one, what do you see? 10 and 1. What else? 5 and 5. Again, remember to put the and. 5 and 5 and 1. What do you notice about those sticks? What do they look like? They look like tallies. Have I taught tallies? When I get to tallies, the kid's going to recognize it. They're going to know there were 4 sticks and 1 stick. That made 5. So the other thing that you see is 2 groups of 5 and 1. Or 2 groups of 4 vertical, for us, not for kids. And then 1 vertical on its own and 2 horizontals. You know what I mean? There's many ways of describing it. Okay. Have a look at the next one when I get to the dots. What do you notice there? It's grouped differently. How's it grouped now? You can have cards for that. There's a group of 10. And the other 2 cards, how was I grouping it? 5. I was talking about 2 groups of 5, and I was still talking about 110. Now the child is starting to learn. 2 groups of 5 is 110. But 5 groups of 2 is also 110. Do you see the commutative coming in? Grade R, grade 1, grade 1 and 2, I've not taught the commutative. They will start to intrinsically understand. So now we talk about 1 group of 10 and 2 single or 2 units. It's very important. This is called unitizing. Learners must not keep counting 10. Once it's 10, we start to talk about 1 group of 10. Not 1, 2, you saw that little boy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 10 must be recognized as its own eonate, its own unit now. And then the 2 ones. And the same, sorry, go back to my apples. How much time do I have left? I'm talking too fast. What time do I have to stop? Oh, thank you. She's holding up a sign, like, look at me, look at me. So, do you notice the box of apples? What can we talk about there? It is 10 and 2, but there's another way I can talk about it. 2 rows of 5 apples and 2 single apples, but another way. Yeah, also 5 columns in a way. 2, another way. What are the apples in? A box. So we can talk about 1 box and 2 extra apples or 2 singles. Right there we've gone into place value. Because it's 110, you know your little 10 blockies? It's 110 and 2 units. This is a very difficult transition kids make because they're used to seeing 10 units. You're not talking about 10 units anymore. You're now talking about 110. Because it used to be 10, now it's 1. And they have to make that transition. And do you see that they can see it? And so when I talk about 1 box and 2 single apples, it helps them in that transition of 110 and 2 singles. Are we together? Okay. So now what is this? Please hold this a moment. What do you see? Repeated addition, 2, 2, 2, 2, 2 columns of 5. So this is 2 columns of 5 or 5 rows of 2. Wonderful array stuff coming. How many of your kids battle with arrays? Be honest. A lot, hey? We haven't taught arrays. We can use this in grade R. By the time we get to officially calling it an array, they're going to have no problem. Because for 3 or 2 years, they've been talking about rows and columns and seeing them. Okay. What else do you see? 1 group of 10. Because I know when all of the dots in a 10 frame are full, it's called 110. But I also see 10 single dots. So there's many different ways to describe this. And that's where I think the beauty lies in avoiding the emphasis on counting. When we teach numbers as counts, the kids get stuck on the number as a count. So they end up counting to add or counting to subtract. Whereas here, they're already composing in creating the number. They're not counting to create the number. And that's what I'm talking about this afternoon as well. So I'm going to allow a question now. It is a pattern within the number. That is what composing a number is. It's composing the next number from previous numbers. Okay, so we'll just finishing off. If you learned a number as a count, what do you have to do here? You have to count. If you've learned a number as grouping or chunking or compositions, hit it please. Can you see the 5 and the 5 and the 3? And you create structure out of that. So that's the difference, that we want to train the kids' eyes to compose groups, not count 1-1, because we are in a counting epidemic. COVID was its own epidemic, but counting is a pandemic in our country. Kids get stuck counting. So I'm not saying we shouldn't count. Counting is a cultural norm. It's not a mathematical tool, actually. It's a verification, but it should not be the foundation of what we do. So I know I'm speaking a big alternative option today, but I do think composition is going to get us much further than counting. Thank you for your time. We are done. So you see how I needed time?
Yes. Thank you. You can see Hannah in action this afternoon, 3 o'clock. Thank you very much. Sorry, no questions. Thank you. Ladies, you must move to your next session. If you want to stay here, you can stay. It's now language. Thank you.